All right, let's talk about the fundamentals of engineering exam. For a chemical engineer, that FE exam can feel like this huge, intimidating mountain you have to climb. But what if you had a map? Well, today we're going to take the official study guide and turn it into a clear, strategic roadmap to help you absolutely conquer it.
So let's start with a big question. What really separates a fresh engineering graduate from a licensed professional engineer? The answer, plain and simple, is passing this exam. It's the critical step, the one that validates everything you've learned and opens the door to your future career. The stakes are high, for sure, but the path forward is exactly what we're here to figure out together.
Here is our game plan. First, we're going to crack open the exam itself, looking at its two-part structure. Then, we'll map out all the topics so you know exactly where to focus your energy. After that, we'll dive into how you need to think, covering the 3 levels of thinking the exam tests. And to wrap it all up, we'll put it into practice and walk through a real sample problem.
Okay, first things first, you have to know what you're up against. Understanding the exam's blueprint, its basic structure, is the absolute foundation for any good study plan. Let's get into it.
Think of this as an all-day event, a marathon, split right down the middle into 2 3-hour sessions. The morning session is all about general engineering, the broad concepts every engineer needs to know. But the afternoon, that's when you get to flex your chemical engineering muscles.
So that first session, it's going to throw 90 multiple-choice questions at you in 3 hours. If you do the math, that's only about 2 minutes per question. So you've got to be quick on your feet. This part is really designed to test the breadth of your engineering knowledge.
Now, compare that to the second session. It's much more focused, with just 50 questions. You still have 3 hours, which means you get way more time per question, over 3.5 minutes. This is where the depth of your chemi expertise is really put to the test.
Now let's talk about the rules of engagement, because they are super important. Everything is multiple choice. And listen to this, there is no penalty for wrong answers. That means you answer every single question. Even if it's a wild guess, you've got nothing to lose. Oh, and you don't have to memorize every formula under the sun. They give you the reference sheets. Your job is just knowing which equation to use and how to use it.
All right, now for the fun part, strategy. With so many topics to cover, you can't possibly study everything. That's where the guide's table of specifications comes in. This thing is basically a treasure map. It tells us exactly where to focus our energy for the biggest payoff.
And just look at this breakdown. This right here is the heart of our strategy. Just 3 topics: chemical engineering principles, mass transfer, and reaction engineering. Together, they make up a massive 38% of your discipline-specific exam. That's almost 40%. If you can get really good at these 3, you are well on your way to passing.
Here's the whole picture. After those top 3, you can see a big chunk of topics like thermo, fluids, and heat transfer, all weighted evenly at 10%. And at the bottom, you've got process control and safety, a little smaller at 6%. This list should be your guide for how you budget your precious study time. Okay, so we know what to study, but there's another layer to this. The exam also tests how you think about these topics. See, it's not just about what you know, it's about how you can apply that knowledge to actually solve problems. The guide calls these cognitive levels. It's a fancy term based on a system called Bloom's taxonomy, but really, all it means is that questions are sorted by the kind of mental horsepower you need to answer them. It's the mental game behind each question.
And whoa, just look at that giant 56% slice. This is, and I mean this, absolutely crucial. More than half the exam requires you to apply what you know to new situations and analyze information. It's not a memory test, it's a problem-solving test. This is the #1 skill you need to practice.
So let's break it down. Level 1, remembering and understanding, that's your basics, recalling facts, explaining concepts. Level 2, that big 56% chunk, is applying and analyzing. That's using formulas, breaking down problems. And level 3, evaluating and creating, is a bit more advanced. It's where you have to justify a decision, maybe even design a new solution.
All this theory is great, but let's make it real. Let's take an actual sample question straight from the study guide and pull it apart step by step so we can see exactly how all these ideas work in the real world.
So here's our question. It's from the process economics section. A plant costs $500 million, its salvage value is $50 million after 15 years, and it depreciates linearly. The question is, what's the plant worth after 5 years? Now, the guide calls this a remembering and understanding question because it's really just about applying a standard formula and process. The key is breaking it down.
Okay, step 1. Let's find the total depreciation over the plant's entire life. We just take the original price, $500 million, and subtract the final salvage value of $50 million. Simple enough, right? That gives us $450 million in total value lost over those 15 years.
Now, since the problem says it depreciates linearly, we can find the depreciation per year. We take that total of $450 million and divide it by the 15-year lifespan. And that gives us a nice, clean number, 30 million SEER of depreciation every single year.
The question isn't about 15 years, though. It's about 5 years. So our next logical step is to figure out the total depreciation over that shorter period. We take our yearly rate, 30 million, and we just multiply it by 5.
And there we go. That gives us 150 million SR. That's how much value the plant has lost after its first 5 years of operation. We are almost there. Just one last step.
So for our final step, we just need to find the plant's remaining value. We go all the way back to the original price, that $500 million, and we subtract the $150 million in depreciation that we just calculated. And that gives us our answer, $350 million SR. See how that worked? We took what looked like a complicated finance problem and broke it down into a series of super simple calculations. That systematic approach, that's the mindset you need for this whole exam. So let's wrap this all up. Here's your strategic blueprint. 1. Know the 2-session structure inside and out. 2. Focus your study time on those top-weighted topics. We're talking mass transfer, reaction engineering, the heavy hitters. 3. Master those applying and analyzing skills, because that's over half the exam. And finally, 4. Practice, 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 breaking every single problem down into logical, manageable steps.
We've laid out the map, we've given you the strategy. The only thing left is for you to take that first step. So the real question is, now that you have the blueprint, what are you going to study first?